Hello friends, this is Dr. Aparna Sajjan from VPKBIT, Baramati. In this video lecture on water technology, we will discuss the process of electrodialysis, which is used for the purification of salt water by a process called desalination. Electrodialysis is a separation technique which uses anion and cation selective membranes that are separated by spacer sheets for the removal of ionic impurities by applying voltage. So in this process, ionic impurities are removed from water in presence of electric current. The principle of this method is the anion and cation selective membranes, they are stacked alternately, and when electric current is applied, ionization of the salts take place into constituent ions, and these ions migrate towards their respective electrodes. That means cations migrate towards cathode and anions migrate towards anode through selectively permeable membranes. And with this, in one compartment we get concentrated water, that is water with more amount of salt, and in the other compartment we get water with less amount of salt or no salt. So the same process is explained here again. The salt impurities present in the water in presence of electric current undergo ionization. For example, sodium chloride is converted to sodium ions and chloride ions. The positive ions migrate towards negative electrode called cathode, and the negative ions migrate towards positive electrode called anode. The charges are opposite, and the positive ions are allowed to pass through cation selective membrane. This membrane is negatively charged. So membrane is negatively charged, therefore it is allowing positive ions. And in the contrast, anion selective membrane allows anions, but this membrane is positively charged. So positively charged membrane allows negative ions to pass. The electrodialysis process can be done in a semi-batch system which is having slow reaction rate, and there is no continuous production of pure water. And in the other continuous system, we have fast reaction rate and there is uninterrupted production of water. So diagrammatically, it is shown here. There are two positively charged membranes called as anion selective membranes or anion exchange membranes, and there are two negatively charged membranes called as cation selective membrane or cation exchange membranes. And you can see here anode and cathode are also shown. Now when feed solution, that is salt water, is fed into the space in between these membranes, now when current is passed, ionization takes place and positive ions are repelled by positive membrane. These positive ions can pass through negatively charged membrane, that is cation selective membrane, and the positive ions are migrating towards the cathode, that is negative electrode. Similarly, negative ions formed are allowed to pass through this positive membrane. Means anion selective membrane is positive, it is allowing the negative ions, but the negative ion is not allowed to pass through cation selective membrane because there is repulsion between the negative and negative ion. Charge repulsion takes place here. So these negative ions are migrating towards anode, that is positive electrode. So from the middle compartment we get water with less amount of salt or without any salt, and from the other side of the central compartment we get the concentrate, that is water with more amount of salt. The same desalination process, we will explain it here. Direct electric current is used for the transport of ions through ion exchange membranes. The terminal compartment houses an anode and a cathode. Already it has been shown in the figure. So when potential is applied, separation of ions take place from the salt water, and these ions can pass through ion selective membranes. So two types of membranes are used. One is preferentially permeable for the transport of anions, and the other is preferentially permeable to the transport of cations. The cation selective membrane permits cations and the anion selective membrane permits anions. And these membranes are alternately arranged in between the electrodes. Now salt water to be desalinated is passed through these compartments, and during the current flow, anions move through the anion exchange membrane in the direction of anode into adjacent compartment, and cations move in the other direction, that is opposite direction, to the negative ions into the adjacent compartment through cation exchange membrane. So the water becomes depleted in ions in one compartment, means water loses ionic impurities in one compartment, and in the adjacent compartment it becomes enriched in ions. That means water becomes more salty. So already the diagram was shown. Now let us see what is the selectively permeable membrane is, or ion exchange membrane is. So ion exchange membrane, they are copolymers of styrene and divinyl benzene. The membrane used in the electrodialysis process are the copolymers of styrene and divinyl benzene. Now, by the introduction of functional groups, it becomes either positive or negative. If sulfonic acid functional group is attached, then the membrane will become cation selective membrane or cation exchange membrane. If quaternary ammonium functional group is attached to the polymer, then it becomes anion selective membrane or anion exchange membrane. But the cation exchange membrane repels the anions, and anion exchange membrane repels the cations. So this is the structural representation of cation exchange membrane with divinyl benzene and styrene copolymer, cross-linked polymer it is, and there is a functional group, sulfonic acid functional group, which is having H plus ion, therefore it is cation exchange membrane or cation selective membrane. And in the other case, quaternary ammonium group is there with OH minus group. So this is replaceable OH minus ion. Therefore it is anion exchange membrane. And lastly, we will discuss about the advantages and disadvantages of electrodialysis process. Electrodialysis process helps for the removal of harmful nitrogen in the form of nitrate ion or ammonium ion from the drinking water. Electrodialysis also removes ionic pollutants, toxic ionic salts, ionic dyes, and small polarized molecules from water. And the desalination process is widely used for purifying seawater and to get the mineral water by maintaining limited quantity of salts in it. It is also applicable to small scale as well as large scale purification of water, whereas RO was only applicable to small scale. This is because we can stack as many membranes as we can in the alternate fashion. Let us see the disadvantages. Only ionic impurities can be removed. Biological, colloidal, organic and other impurities are not removed from water. They are retained in water. Or other techniques should be used to remove such impurities. And these membranes can be affected by biological impurities. They may be attacked by bacteria or fungi. And therefore, the maintenance requirement of these membranes is more, and the cost of the process is also more. This is the end of this video lecture. Thank you for listening to the video.